Finishing up problem number 5 where we left off at the end of the last video. Unfortunately, we only have a 15-minute time limit. But for number 5, we had a rotation through about the origin through 180 degrees, always being counterclockwise, just as we studied in trig. Where did the point -2, 6 come from? Well, you can see up here from where we left off, we know that the image and pre-image are related through this matrix equation. Following up down below, you can actually very quickly multiply the matrix -1, 0, 0, -1 to xy, this 2 by 1 matrix. You can do that on the 89 certainly, but let's review how to multiply matrices. We're going to go row by column. -1 times x would be just -x. 0 times y is 0, so we'd add a 0. That's going to be your top row. Your second row, you take your row by column, 0 times x times -1 times y, so we'd just be left very simply with opposite of y. So very quickly, what are we seeing? We're seeing this, and you might remember by in pre-calculus studying symmetry about the origin, you can pretty much see these equations right here. We would be able to be transformed that our image would be opposite of x, and our image of y would be the opposite of y. So for number 5, they're saying, where does the point -2 and 6 come from? Well, -2 and 6, when they're saying coming from, this means where it ended. So of course we'd say -2 would equal opposite of x, meaning x of course would equal 2. We'd say 6 would equal opposite of y, meaning that y would equal opposite of 6. 2, -6 is the pre-image. That's where -2, 6 came from. Alright, well, let's take a look at actually not just rotating points in terms of working problems out with images and pre-images simply with an ordered pair for one or the other. Number 7 actually and number 6 are far more interesting, and they really do get far more involved. So let's take a look at number 6. We're going to say the curve x squared minus y squared equals 1 is rotated about the origin through 45 degrees. Find the equation of the new curve. Well, my goodness, this problem really can be done a couple of different ways. We're going to be transforming all of the points. Very quickly, let's write out that our image would equal the cosine of 45 degrees, opposite sine of 45 degrees. Down here we'd have the sine of 45 degrees, cosine of 45 degrees, times x, y. Tell you what we'd like to be able to do. Ideally, we would like to know what x is equal to and what y would be equal to, so that we could substitute those expressions into the equation that we're asked to transform. We're asked to transform x squared minus y squared equals 1. This is the curve, an infinite set of points that will be rotated 45 degrees. My goodness, we'd wonder how on earth can we do that? Well, tell you what, this is really a great way to approach this problem, and it's a very, very powerful way to attack this. Look, if I may, I'm going to call the x prime, y prime, I'm just going to call it a matrix capital X prime. Okay, just symbolically writing that. I'm going to call this matrix the transformation matrix A, and I'm going to call this other matrix X. Now the question is, how do I get X alone? Well, we can't divide both sides by matrices. Matrix multiplication is the only thing that we can have. However, we can multiply a matrix by its inverse. Now, please understand that matrix multiplication really it depends on order. It matters what comes first or second. I have no choice but to put A prime, the inverse of A, in front of A, that is to the left of A. And then I'd have to do the same thing over here. Now, what am I really getting at? A inverse times A is going to be the identity matrix. It's going to be I. So if we continue up here in this corner, we could say this left side was A inverse X. The right side would be the identity matrix times X, and of course there's X prime. The identity matrix times anything is itself. Why would we do this? Well, my goodness, now we can have an equation for X and for Y. We'd be able to then substitute it into any equation that we'd like, and we could find out how it is transformed. But of course, we need to get an inverse of our matrix. So tell you what, let's use our 89. The 89 is just wonderful. We'll turn this on. We've spoken before about how to get a matrix entered in. We know that the cosine of 45 degrees is really 1 over root 2. And yes, it's really radical 2 over 2, but it might even be a little more quick to just be able to write 1 over root 2. So that's what I'm going to do. Say 1 divided by second multiplication. That did not take. We'll try it again. There we go. 2, close our parenthesis. I'll say comma. The next entry would be the negative 1 divided by radical 2. And from here we'll hit semicolon. Semicolon means that we're done with a row. And then if you're really thinking about it, we're just going to say 1 divided by root 2. Put one more comma in there, and then say 1 divided by root 2. So close your parenthesis, close your brackets. This is a way to represent a matrix in the TI-89. There are other ways, but notice what I'm going to do now. I'm going to say raise that to the -1 power. This is how a matrix will be represented with its inverse. Raise something, a matrix, to the -1 power, and this is what we get. You can see we are rationalizing. So I'm going to move this off to the side just a little bit. You can see the top entries are positive, bottom left is negative, and then we'll have a root 2 over 2 down below. So what am I getting at? Tell you what, we're going to do the following. We're going to say over here is x comma y. This matrix, like I just said, it was 1 over root 2, -1 over root 2, 1 over root 2, 1 over root 2. But what are we seeing? We're going to see that the inverse matrix that we'd like to multiply by is this form. What we do to one side, of course, we have to do to the other side. So I'm going to have to multiply by this exact same matrix on the left, over here, on the left-hand side, in fact. Now look, here's the wonderful thing about multiplying by an inverse. You can even multiply these two together on a calculator if you'd like, but this wipes out to the identity matrix. This is going to essentially disappear. What's the benefit? This right-hand side will simplify really to the identity matrix times the matrix xy, which will just be xy itself. Now, over here on the left, of course we could multiply through. We could definitely do that. That's not a bad thing to do. We could multiply through via the calculator, but you know what? You want to be able to gear up and save yourself some time. Row by column root 2 over 2 times x prime plus root 2 over 2 times y prime. How about down below? Negative root 2 over 2 x prime plus root 2 over 2 y prime. Okay, so what are we seeing? We have equations for x and for y. What am I really getting at? X is equal to, you don't have to write this as a matrix. You could just say, hey, look, this is my x, this is my y. And tell you what, this curve that we were given is going to be transformed. We can say, what's happening to x squared minus y squared equals 1? What's going to be its appearance? Well, we could put this all in here. And by the way, let me tell you what's really cool. When you've got root 2 over 2, you can just factor that out. By the way, here's a cool way to do this. Pull out 1 over root 2 for both of these. Remember, radical 2 over 2 is 1 over root 2. Look at that. Okay, why am I doing that? I'm going to substitute. I'm going to say, look, this is 1 over root 2 times, here's my x prime plus y prime. I'm going to square that all. Okay, square that whole thing. I'm going to say minus. Over here, I'm going to get 1 over root 2, and I've got my opposite x prime plus y prime. And by the way, if you want to do something clever, you could just put your y prime minus x prime in here real easily. Square that. Where are we going with this? Well, you square 1 over root 2, you're going to have a half. Then what? Just FOIL this out. You'll have x prime squared plus 2x prime y prime plus y prime squared. Then we're going to say minus, well, right in here, square the 1 over root 2, and we'll have 1 half. But then what? Well, I'll tell you what, we can square all these terms. Y prime squared minus 2 x prime y prime plus y prime squared. And that's just going to equal 1. Well, we're getting there. We're certainly getting there. Tell you what, how about we multiply both sides by 2? If you multiply both sides by 2 and distribute, very simply, you'd get a 2 over here. That can get rid of the halves, make it a little bit nicer. Look, you've got x prime squared plus 2x prime y prime plus y prime squared, but you've got to distribute this negative, minus a y prime squared plus 2x prime y prime minus, and this last term actually was an x prime squared. Well, look what's about to cancel. The x prime squareds are going away. One's positive, one's negative. Same thing with the y prime squareds. You'd have 4x prime y prime equals 2. A couple things you can do. You can divide both sides by a 2. And you know what? Very typically we drop the primes. This is the equation of our new transformed figure. We could also say that it's y equals 1 all over 2x. So how is this x squared minus y squared, which is a hyperbola, you should remember from pre-calculus. This hyperbola is rotated 45 degrees. This would be its new equation. Very often at the very end we drop the primes. So multiply both sides of a matrix equation by the inverse of the matrix. The wonderful thing is you will have the pre-image matrix isolated. Then you will know what x would equal and what y would equal. Once you know what x and y equal, substitute those expressions into your original equation and you will be on your way to finding your new transformed equation. We'll keep doing things, but this was a very, very important problem. The techniques used here are used often. Keep working.